Thank you all for joining us for today's AppFabric series webcast, AppFabric plus Service Bus, presented by Rick Garibay. My name is Meredith Mead, and I'm the marketing coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by Rick Garibay, Neudesic's general manager of the Connected Systems practice. If you're all logged on, you should be able to see the title slide that states Neudesic. There's a brief intro earlier regarding features within Live Meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note all questions will be held until the end. We will also be using the speaking chart feature within Live Meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. This webcast is being recorded and will be available via the Neudesic website. We will email you the link when it becomes available. Before we kick off the webcast, we'd like to know how you heard about this webcast. We'd greatly appreciate your participation in a quick poll. Give it a few more seconds for everybody. Great, thank you. At this time, I'd like to turn our presentation over to Rick.
Thank you very much, Meredith, and good morning, everyone. Welcome to the Neudesic webcast series on AppFabric. My name is Rick Garibay, and I will be spending the next hour or so with you doing a continuation of our series on AppFabric by diving into the AppFabric Service Bus. I'm going to go ahead and just share my desktop here. And everybody should be able to see the title slide here of the presentation. Is everybody able to see that?
Looks good, Rick.
All right. Well, thank you, Meredith. As Meredith mentioned, my name is Rick Garibay. I'm the General Manager for the Connected Systems Development Practice at Neudesic. I'm also a four-time Microsoft MVP focused on connected systems, and I sit on a number of advisory boards with Microsoft to provide feedback and work directly with the product teams providing feedback from folks like you in the field, customers, etc., to make the connected system stack the best that it can be. I'm also the president and the co-founder of the Phoenix Connected Systems User Group. So if you're ever in Phoenix, Arizona on the first Wednesday of every month, please feel free to stop by. We'd love to have you. And you can reach me via email, Twitter, or on my blog. So with that, enough about me. Let's go ahead and jump right in. As Meredith mentioned, this is actually the third in a series of webcasts on AppFabric. The first two webcasts were really a focus on what's new in WCF 4 and Workflow 4 workflow services, which really kind of form the underpinnings of AppFabric. And so it's important to really understand those fundamentals and have an appreciation for what those technologies provide, because you'll really work with WCF and Workflow when building solutions on AppFabric. I'll provide links to the previous webcasts towards the end of the session so that you can review those and refresh on those technologies if that's something of interest. And this third webcast focuses on Service Bus, which is really the solution or technology that you'll use to actually build hybrid composite solutions. And we'll talk more about that. And the final webcast in February, and we'll provide more information towards the end, is really tying everything together into how to build hybrid composite applications in the enterprise with AppFabric. And we really think that AppFabric is the new platform for Microsoft middleware. That is the platform that you'll use whether you're developing, deploying, and managing applications on-premise or in the cloud. So we really appreciate you taking the time to learn more, and we'll go ahead and get going. So looking at the agenda, we're going to talk about some of the challenges that are inherent to delivering software plus services. Software plus services being Microsoft's vision for how to provide the best of both worlds with client software running on-premise and applications and services running in private and public clouds, and really has been the mission and focus of Microsoft in terms of delivering these composite solutions. We'll take some time to understand at a very fundamental level the service bus integration pattern and what problems it solves and the core capabilities that you'd expect from any service bus. And then we'll actually take a look and spend the rest of the time diving into the AppFabric service bus, starting with the key aspects of the bus, and then look at the different bindings that the bus provides in support of different messaging scenarios. And then we'll actually do a bunch of demos showing how to do one-way messaging on the edge, where you might have a client that is running in a private cloud or a different enterprise data center somewhere, and the ability to actually surface an application really anywhere in the world over an internet connection and exchange messages with that client. We'll also look at hybrid eventing, an approach for doing multicast messaging, really from anywhere in the world, as well as looking at what the best practices are for optimizing performance on the edge and beyond with the NAT TCP relay binding. And we'll wrap up with a discussion on some of the features that were announced at PDC 2010 that are certainly exciting as the platform continues to mature. So let's talk about some of the challenges that we face today in delivering hybrid composite apps around the software plus services premise. When we think about software plus services, the canonical example is that in which you have maybe a rich client that is sitting somewhere in the enterprise, on-premise, perhaps in the edge, and you want to be able to provide the best user experience for your end users or customers, but are really leveraging location transparency and service orientation to really provide this logically centralized but physically distributed approach to delivering the resources, information, and value to your applications. And so one of the common message exchange patterns that we've been using for over a decade at least is a one-way message exchange in which you might have a client that sends a message to a service over the internet or some kind of a private cloud, and the message is received by the service, and the service may conduct some asynchronous program processing in the back end, doing some kind of a work without any real feedback, but certainly acknowledging that the message was received. The other approach that is very common is that of request response, and we've been doing request response for quite a long time as well, and that's very similar to the one-way message exchange. The difference now is that the client expects a response to the message that it sends to a service, and so again, in this case, you may have a client application that's sitting in a data center that's consuming a service out on the internet or perhaps in some private cloud, and that becomes relatively simple to accomplish, given the fact that the capabilities for consuming resources over the internet have been available to us for several years now. So the process by which that works is you send a message from the client, during which time the client blocks, and the message is then received in response. And so again, the client sends the message is received by the client, and you expect that message to come back in a relatively short period of time. The problem with delivering on the premise of software plus services and really delivering these hybrid composite apps is that the reality of the fact is that if you're truly going to leverage software plus services, you really need to transcend how we traditionally think about the data center, right? And so you may have a number of applications and or services that are residing on-premise, that is your traditional data center, and then a number of services that might be hosted in traditional hosting providers, maybe in different cloud provider offerings. And so the idea there is that you send a message from your client to that service, which again, we've been able to do for years, and that might be a one-way service call, might be a request response call, but the challenge becomes that when that service is going to respond in a non-request response manner. What that requires actually is the ability for that service to gain connectivity from the outside into your data center or your application running on premise. And that's something that's significantly more challenging to accomplish for a number of very good reasons. And so let's jump into those, having defined hybrid composition. So the reason that there's a lot of challenges inherent to truly delivering software plus services in a hybrid composite manner that really transcends on-premise and cloud is that there's a number of provisions that have been put in place over decades of really fortifying the enterprise. And those include things like network address translation, which we'll jump into a little bit further and define, just probably be a review for most of us. Then provided that you are able to work through the challenges that NAT provides, you may find that you have a network firewall to deal with. And then in today's day and age with modern operating systems, most end user applications or operating services, are provisioned with a software firewall. It's become very much a commodity offering to really secure that user experience within their operating environment. And so the reality is that when you try to then have a service on the outside communicate with a application or service on the inside, there's a number of different boundaries that provide challenges. So let's quickly review network address translation. The whole idea behind NAT, or network address translation, is that really you have one single IP address that's publicly assigned that might be shared with a number of internal machines. And the reason for leveraging NAT as a very common approach is to address the fact that really we run out of public IP addresses for all intents and purposes. And so the benefits of this is that it allows us to do more with less, meaning that you can pay a broadband provider or a infrastructure provider for a number of discrete public IP addresses that then you distribute internally using private IPs, and then the users are seamlessly able to connect to the internet and other resources. The problem with network address translation in terms of thinking about composite hybrid scenarios and software plus services is that the public IP address may change. So even if you're able to determine what that IP address is and you do some port science or port magic and figure out what ports to open, that IP address may change, and certainly the IP address of the internal machine hosting the service is unknown, which does create some overhead in terms of mapping outbound requests into inbound requests, opening up ports, mapping ports, et cetera, et cetera. So network address translation is very useful in the traditional sense, but does introduce some challenges in truly transcending the boundaries that currently exist between on-premise and cloud composition. Think about network firewalls. The whole reason for firewalls is that the internet is full of bad guys, right? And so we want to let the right guys in, but keep the bad guys out. And network firewalls have been very, very proven in doing that. But again, the problem there is that you might have some applications that aren't part of your enterprise, aren't part of your data center, for which there isn't a traditional trust that you actually do want to authorize to be able to interact with and exchange messages with. And that's really where the network firewall can become very limiting, because the process by which you go to open the inbound ports that are typically required to enable this hybrid composition is by design perhaps very cumbersome. You want to be very careful about what ports you're opening for inbound communication, what the rationale is, because folks that have been really working in ensuring that the surface area of your organization or enterprise is minimized are rightfully concerned about opening ports. And so the process of opening outbound ports is typically more relaxed, and really it's the inbound ports that will really give you the most challenges in really getting those ports open in time to deliver on your solution. But certainly the culture and the policies for many organizations vary. And while some organizations may have a relaxed approach to outbound ports, excluding HTTP. You can typically count on HTTP being available, but your mileage will certainly vary. And regardless of what approach you take, again, opening ports, doing port mapping, etc., is something that is very, very maintenance intensive. And lastly, the software firewall, as I mentioned earlier, provides now a additional layer of security for the end user that then requires the end user to become, somewhat familiar with the type of traffic that is, entering and exiting the operating system. And while some power users have no problem doing this, a typical end user that might be leveraging your application or your solution probably doesn't want to be bothered with that level of minutia, right? And so we need a way to provide the same levels of security that a software network firewall and the ease and flexibility that NAT provides, but at the same time kind of accelerate the rate in which we're able to actually deliver on these hybrid composition scenarios and actually, again, erase these boundaries between on-premise and cloud. So let's actually jump into that. And before we get into the details around the Azure AppFabric Service Bus, I want to start by just talking about some fundamentals around the Service Bus integration pattern. So when you think about a service bus, really the idea behind a service bus is to make publish and subscribe or enabling publish-subscribe scenarios as easy as possible. And the best example for understanding pub-sub is you have a client that might send a message or publish a message on some kind of a messaging fabric, and that messaging fabric may be exposed via a number of different communication protocols. And then the bus is typically chartered with determining what subscribers or what parties actually care about that message. And that actually divorces the client application of those intimate details, which provides a lot of flexibility in terms of agility in providing these integration scenarios. And the service bus then, having looked at subscribers, delivers that message. And that really fundamentally is why pub-sub is such a popular design pattern for doing integration, and that it decouples the client from the service and then also allows you to gain visibility centrally over the traffic that's happening and actually make changes to the destinations and endpoints without the client really being concerned. The client only is aware of a endpoint that is exposed by the messaging fabric or the service bus, and then basically sends messages that conform to whatever policies and contracts have been established. And that's pub-sub in a nutshell. And so any service bus that you evaluate will at its core have pub-sub as a capability out of the box, and then a number of different capabilities that really kind of are built out around that. And those capabilities typically, in addition to messaging, include things like routing, orchestration, transformation, so the ability to automate business processes, map from one representation of a message to another, depending on the contract that a target endpoint expects. Certainly the ability to catalog the different endpoints and provide some management capabilities, and then often security and monitoring capabilities for determining what clients are able to send messages over the messaging fabric, and likewise what services are authorized to connect and receive those messages, etc. Things like encryption, message integrity, etc. Are typically capabilities that you'll find as a cross-cutting concern, along with monitoring, getting visibility as to what's happening within the enterprise, what messages are being exchanged, and really now gaining a higher level of awareness in terms of what the impact to messages are to the overall business. So, starting with that fundamental baseline of what typical service bus provides, regardless of vendor or platform, let's actually dive into the AppFabric Service Bus. So the AppFabric Service Bus, in mapping to those core capabilities that I talk about, provide a naming structure, a service registry for actually exposing or cataloging those endpoints that you'll name, and we'll look into that here very shortly. And then certainly the messaging fabric, which really is the core of the ability to provide this connectivity seamlessly between clients and services or publishers and subscribers. And then there's a security aspect as well to the AppFabric service bus that's delivered by the Access Control Service, which is also part of AppFabric, that I'm not going to cover as part of this webcast, but certainly is something that you want to look into, which provides a claims-based federated approach to actually securing your applications and services. And so as we'll dive into the demo, I'll show you the approach that I'm using for securing the exchange, but certainly the Access Control Service is a topic into and of itself. So let's actually start by jumping into naming. In the AppFabric service bus, naming takes the approach as displayed here on this slide, where you define a root, and the root is actually the name that you provide when you sign up for the AppFabric service bus service. It can be really anything that you'd like, provided that someone else hasn't already taken it. And you can kind of think of that as the root DNS name that clients and services will use to actually resolve your endpoints. And then there's a service namespace that's provided by Microsoft, along with then the ability for you to build out your own taxonomy. And so what that might look like is root, which would be whatever you would provide, .servicebus, .windows.net, and then here you can see a sample taxonomy, in which case we might be connecting a purchase order system or a fulfillment system where you have orders, and then you distinguish between maybe existing orders and new orders, and maybe segment that out by market geography. So you may have a endpoint name of root.servicebus.windows.net, whack orders, whack new, whack Arizona. You'll notice the SB protocol prefix. That's actually a prefix that's reserved to specific service bus bindings, and we'll actually jump into that here in a little more detail as we progress. So to wrap up on naming, the root can be any number of URI schemes depending on what your goals are for connectivity. I mentioned the SB or service bus scheme is a protocol scheme that's reserved for specific bindings that are provided by the service bus, which we'll jump into shortly. And then certainly the support for HTTP and SSL URI schemes is supported as well. The solution namespace, again, is one that you'll provide. In the case of these demos, we'll use mine that I've actually registered with Azure AppFabric as Rick Garibay, and then whatever taxonomy hierarchy that you provide. So having defined what the naming structure is, let's actually talk about the service registry. So the service registry is a catalog of service endpoints that allows you to publish endpoints that you want to make available for discovery to the discovery service. And so the catalog is actually exposed using an Atom feed that you use your browser or a HTTP capable client to consume and expose. And what that allows you to do is publish your service endpoints to make those available and the availability of those known to consumers. Now, the important thing to understand is that the catalog or the service registry, just because a service endpoint is browsable, does not mean that you have the authorization to consume it. So it's strictly for publishing and discovery purposes. And you can see a code snippet here of how you go about publishing an endpoint by adding a service registry settings behavior as part of your WCF service initialization. So we'll spend most of the time dealing with the messaging fabric and really understanding that, because the naming and the service registry kind of come along with your understanding of messaging fabric, and we'll show you. I'll show you the approach that we take to defining a taxonomy, registering a service with the service registry, and then we'll actually focus on sending messages, back and forth using the service bus. So if you're familiar with WCF, the AppFabric service bus is really based on WCF as a model for delivering the capabilities that you'll need in order to provide seamless connectivity really from anywhere in the world, provided there's an internet connection. And so if you're familiar with WCF, these binding names will be very, very familiar to you. And for those that might be new to WCF, WCF is really a unified framework for delivering messaging across a variety of channels. So it really unifies what used to be enterprise services, CommPlus, ASMX web services, remoting into unified API that actually allows you to create your service logic and actually build your services in a manner that's independent of the transport. And what you do is having focused on the actual value and purpose of the service, you actually relegate the selection of bindings to a deployment kind of decision, which allows you to host a service with a number of endpoints that actually are exposed using a binding, and thus making your communication protocol policy decisions accordingly. So with that, the bindings are shown here, and each of the bindings provides a different approach for connecting application services to the AppFabric service bus. The basic HTTP relay binding complements the basic HTTP binding, which provides WSI basic profile 1 request response capabilities over HTTP or HTTPS. So if you have some legacy clients that might be exposed using ASP.NET Web Services or ASMX, or a service on another vendor stack such as Java, for example, that conforms to WS basic profile, this is the binding to use to actually expose that service to any consumer, again, anywhere that it can establish a connection to the internet. The HTTP relay binding is the complement to the RESTful binding in WCF called the Web HTTP binding for exposing RESTful services over the bus. And then there's a number of other bindings that are shown here. We'll actually take a look at the NET TCP relay binding, which really is the recommended binding for delivering the highest performance and optimized connectivity for service bus scenarios. Also, the net one-way relay binding and the net event relay binding are actually two bindings that don't really have an equivalent in the traditional WCF stack. But the net one-way relay binding is a very smart and optimized binding that supports one-way messaging or datagram messaging. And then the net event relay binding is based on the net one-way relay binding and provides multicast pub-sub type communication. And we'll demo all three of those as we progress. So really the idea is that if you're comfortable with WCF, getting up to speed with the service bus will be seamless. And if you're new to WCF, I definitely encourage you to take a look at WCF, as it is really the superset and represents the future messaging platform for Microsoft. So a couple of limitations to the service bus. Today, by design, atomic transaction flow is not supported, and the protocol level transport authentication is something that currently is not supported as well. So let's actually jump into the bindings. The net one-way relay binding is a smart, optimized datagram messaging binding that allows you to actually create an outbound socket using TCP and then establishes a bidirectional mapping onto that socket. And this bidirectional capability of actually exposing an outbound socket and enabling bidirectional communication is really kind of the magic behind what makes the service bus so unique. And we'll get into that with some illustrations and some demos. Now, the default when you use the net one-way relay binding is SOAP 1.2 over TCP with .NET binary encoding. So we're doing SOAP 1.2, but we're encoding it with binary to optimize the transfers over the internet. And the way it works is the service establishes this bidirectional outbound socket to the relay service, which is a key part of the messaging fabric found within the AppFabric service bus, over port 828, which is a secure TCP port. And you have to mark the operation contract on your service that you'll actually be exposing over the service bus as one way. We'll actually take a look at some code there. And the client then establishes a one-way connection with the relay service over TCP port 808 or 828, depending on whether or not you want to establish an outbound SSL connection. And then certainly the same bindings are required on the client and the service. And if you've done WCF, you know that binding equivalence is something that's required for any client-service interaction. And then really what happens is the relay sends a one-way message to a single endpoint listening on the service bus address. So let's actually show a diagram that I think will help you picture this. So you have the messaging fabric here, which really is the AppFabric service bus, and at its core is that relay service capability. So the idea there is that you have a client and a service, and those clients and services may be behind network address translation, network firewall, software firewalls, really doesn't matter. The idea is that the service will create an outbound connection via port 828, which then establishes a connection on a listener node on the messaging fabric. And the client then establishes a outbound connection as well to a client node. That is a node dedicated to the client that you'll actually reserve when you set up your AppFabric service bus account over port 828. And then what happens is because there is a connection to the relay, to the messaging fabric, the client can then send the message to the service bus, and the service bus will ensure that that message is routed to the service regardless of where that service is hosted. So as long as that service can create an outbound connection over TCP on port 828, the client can communicate with that service. And the key to remember here is that that service could be hosted in a data center, could be hosted on your company's network, could be hosted in a private cloud, a hosting provider, or a friend or colleague's machine that needs to be able to receive messages, maybe notification services, etc. So very, very powerful conceptually what the service bus provides from a capability standpoint. But one of the things you might immediately respond with is that, not all organizations are going to have support for creating an outbound TCP port, and that certainly is true. And so we're actually going to show some alternatives to that as we dive deeper here into the bindings. There are a couple of connectivity modes that you want to think about when you're using this binding, and these are configured at the app domain level, the application domain level. So you can choose TCP, which is what we just went over, HTTP, which means I know for a fact that the network firewall, software firewall, etc., is prohibiting outbound TCP connections. So please don't even try it. Go ahead and use HTTP because we know that's going to work. Or when you don't know, as is in the case in transiently connected scenarios or scenarios where, again, you don't really have visibility or care where that client or service is deployed, all you know is that you want to enable one-way communication, you can actually set the system connectivity mode to auto-detect. And when you do that, what basically happens is that the same process that I showed earlier takes place, except in this case, the service will first try to establish an outbound TCP connection over 828. And it'll try that a number of times. And once it's failed, it basically gives up. And at that point in time, it creates an outbound listener over the HTTP channel using port 80, which is going to be very consistently available, except for the most extreme lockdown scenarios. And when that happens, then the client continues to establish its connection on TCP port 828 in this case, and can then establish communication with the client. So this is a very resilient approach for ensuring that regardless of the network topology, regardless of what the policies are in place, that your service is actually listening and available to start processing messages from anywhere in the world, provided that there's a internet connection between the two nodes. So let's actually do a demo of this. I want to show you one-way messaging in action. I'll show you the service taxonomy that I've defined for this first demo, the code required to publish the service to the service registry that we'll then look at in a browser as an atom feed, and then we'll actually send a one-way message using the net one-way relay binding from two completely divorced networks. So the first thing I'll actually show you is that I'll have a service that's actually going to be started on my laptop that I'm actually running this demo off of, and I'm using I don't want to plug my provider, but I'm using a residential broadband provider to establish my connection to the internet, same pipe that I'm presenting to you on today. And then I'm actually going to start a client from a virtual machine in a private cloud that is in a completely different network than my own, and the only connectivity that it has is the internet and the ability to actually route through or tunnel through the internet. So with that, let's go ahead and get started. I'm going to bring up Visual Studio here, and what I want to show you first is a very trivial implementation of this service, which is a WCF service. And I want to show you that really nothing about the service is different than the way that you would approach a WCF service. So here's an example from the service bus samples. It shows that there is a service contract that I've defined that is called I-one-way contract. It contains an operation called send that takes an integer and is void, and it is a one-way operation as defined by the policy inherent to the binding. And the implementation of that service is equally trivial. I simply implement the I-one-way contract interface, and then the actual operation is the send method. And all I'm going to do here for the demonstration of this demo is write the message receipt out to the console to provide some level of interactivity. So with that, what I'll go ahead and do next is just give you a quick overview of the client. The client itself is a console application. The console application is going to use a WCF channel factory to create a connection to the relay service or the service bus. And once it's done so, it's simply going to send 25 messages in sequence over that channel that then should arrive at the service that is listening on my machine. From a hosting perspective in this demo, all I've done here with the service is created a self-hosted service. You can also use server AppFabric as a first-class host for hosting your service bus enabled endpoints. And what I'm doing here is prompting for the service namespace, which is that root that we talked about, and then I'm using a helper method here called create service URI that'll actually build out that endpoint name for me. I then create a service host just as I would any other service host, providing the one-way service that we just reviewed, along with the address that the create service URI helper method on the service bus environment provides me, which, by the way, all you need to do is provide a reference to the Microsoft.ServiceBus. And what you'll notice here is if we look at the references, we're leveraging the Microsoft.ServiceBus assembly, which you download as part of the AppFabric SDK, and then plain old vanilla WCF assemblies, including the system.service model and system.runtime serialization. So with that said, once the service host is created, I actually, in this case, want to publish the endpoint to the registry service. And so I do that by instantiating a service registry settings behavior, setting the discovery mode to either private or public, and then I actually just add that service registry settings behavior to the service endpoint itself, and I open the host, and at this point in time, using the binding, I'm ready to start receiving messages over the internet. Now let's actually show you also the configuration, because I want to jump into that here very briefly. From a WCF perspective, as I've mentioned, it's really no different than any other WCF service. You'll notice here I have my service element along with my name, my address, my behavior configuration, and my binding here is net one-way relay binding, which is the binding that we're going to demonstrate here, and the other canonical ABCs that are inherent to WCF. Now, I do have a behavior configuration, and in that behavior configuration, I'm actually including the shared secret element, which is the most simple way of actually securing your endpoints. And this is actually a shared secret in which both the client and the service have to provide this token as a claim in order to establish connectivity to the bus. So it's actually very secure in the sense that if you don't have this shared token or this shared secret at the most fundamental level, you will not be authorized to exchange messages. And I'm not going to share the rest of my issuer secret because it is mine and I do pay for it, but you'll get your own secret key when you establish your own AppFabric Service Bus account. So with that, in terms of binding equivalence, you'll find the same exact thing on the client side. We have a client endpoint this time that is also using the net one-way relay binding. So what I want to do now is I want to go ahead and start the service. I'm going to enter my namespace, which is the root that we talked about. And when I do that, I'm going to go ahead and echo here that the service is listening, and I'll just write to the console that fully qualified URI. And so what you'll see here is the use of the SB protocol scheme, which is unique to this binding, and then the root name followed by the servicebus.windows.net. I scroll over here a little bit, and then the actual taxonomy that I created for this demo. So at this point in time, the service is ready and it's listening on my laptop. And now what I want to do is actually jump into a virtual machine that I actually have running in the cloud, in a different cloud provider. And let me go ahead and bring this up. Bear with me here. Hopefully everybody can see my screen. Okay, so now I've actually remoted into a virtual machine that I believe is hosted in the Washington Pacific Northwest. And having established my service listener here on my own machine over my commercial broadband connection, what I want to do now is actually start sending messages from this client application that just happens to be hosted in a different network, completely divorced from my provider's network, obviously. And so I haven't created any firewall rules. I haven't had to, open any inbound ports. So what I'll do now is just go ahead and run this client here. And I will go ahead and try to get this all on the same screen. And so now what I'll do is I'll hit enter. The client opens the channel and starts sending messages over the internet, which are instantly received by the listener on my own machine. I think that's pretty cool. So in this demo, I showed you how to define a service taxonomy. We published a service to the service registry. Oh, I just realized I forgot to show you the service that's published. So let me go ahead and refresh here. I have a HTTP and then the name of my service bus reservation. And if I click F5 here, we should see that the one-way service was in fact published and is consumable for discovery purposes over this item feed. Okay, so we looked at how to do one-way messaging from really anywhere in the world to a service that is listening anywhere in the world as well, provided that an internet connection is available between the two. And the previous binding is fantastic for doing one-way messaging, but you might have situations where you want to send a message to the service bus such that a number of different listeners or subscribers are interested in that message. And so a great example of this might be the classic purchase order scenario, right, where you have in an e-commerce scenario a order that comes in, and there's a number of different parties that might be exposed via application services on-premise, in the cloud, different hosting providers that actually care about new orders, right? There's inventory processing that needs to take place. There's warehousing and actually pulling the product from the shelf, shipping, billing, etc. So that's a really good example of where multicasting is useful. And so the net event relay binding allows for you to basically do everything I just showed with the net event binding, but actually provide that in a fan-out manner such that multiple subscribers can receive it. And so the way that works is that the service establishes a bidirectional outbound socket to the relay service over port 828. You can use transport or message security. You have to mark the operation contract as one way, just as we reviewed in the previous demo. And then the client, once again, establishes a one-way connection with the relay service. And the relay will then send a copy of the message to each endpoint that has established a connection on that name, on that reservation. So here's an example of that. We have a number of different services that have established a connection to the service bus. A client connection is also established. The message is sent and then delivered to every service that's interested in receiving the message. So let's actually take a look at this eventing model for enabling hybrid applications, both on-premise and in the cloud, by taking a look at the net event relay binding. So go ahead and close these guys. And let's go ahead and start the net event sample. And in this case, I'm just going to keep everything on my machine, both from a client and a service perspective. But keep in mind that that in itself is not trivial either, because one of the common scenarios beyond the ability to exchange messages from different locations is I may want to enable the ability for a departmental application to communicate with another application, and I don't have the time or the resources to actually go through all of the process from a change control perspective that may be required to enable this, and provided that there's some guidance from leadership. It makes sense to actually accelerate the time to market for some of these departmental apps. So I may want to go ahead and expose applications within my same network in different geographies and different office locations. So here the implementation is really identical to what we showed before. The only other difference is that we're now using the net event relay binding. Everything else is pretty much the same. And so now what I want to do is actually come in here, and I'm just going to go ahead and start 3 instances of the service. I'll just pause here to get each of those registered. We'll just start with, there we go, there's the 3rd one, great. So I have 3 instances of the service that are listening on my machine, and now what I'll go ahead and do is just start up my client. and I'll provide my namespace here and just start pumping messages. And so we can see that 25 messages were sent, and we should see that each of the 3 services received all 25 messages. So again, the net event relay binding is a great way to do pub/sub, where you have a number of different subscribers that are interested in a message and receive the ability to receive that message in a one-way manner. Okay. So moving right along, the basic HTTP relay binding, as I mentioned earlier, is comparable to the basic HTTP binding. It supports both transport and message security, just like any other WCF service. The service starts off just like a net one-way relay binding. The client establishes an outbound connection over port 80, and then the service actually receives a control message from the fabric with a node that the client is connected to and establishes a rendezvous connection with the client on the same node. And so the relay is used initially to actually communicate what that rendezvous socket is, and from that point, then the service establishes a connection to that rendezvous location, which results in optimized communication. So again, the service establishes its outbound connection, in this case over TCP 828. The client establishes an outbound connection over port 80 HTTP. A control message is sent to the service, at which point now the service knows what port to go ahead and meet the client on, and that socket is established, and now at this point the client and the service can exchange messages. Other web bindings that you want to be aware of work the same way. I have a list of them. So as I mentioned earlier, if you are working on RESTful scenarios where you're exposing the underlying application over REST to maximize the ability of consumers to interact across platforms, or consumers that don't have readily available SOAP stacks, you can use the web HTTP relay binding. And for more sophisticated WS star scenarios, the WS2000 HTTP binding is the equivalent there. So I want to spend the rest of the time we have together on the NetTCP relay binding, because this binding really is the most performant, and is the one that Microsoft and Neudesic recommend that you use whenever possible. It's equivalent to the NetTCP binding in WCF, which is going to give you a high degree of performance and optimized transfer via binary encoding. Again, it supports transport and message security. And in this case, again, the service will start just like any other net one-way relay binding. The client now this time establishes an outbound connection with the relay service over TCP port 818. And the service again receives a control message from the fabric with the node the client is listening on, and the rendezvous is established in the same manner as demonstrated before. So here's that in action. Service establishes a connection, as is the client. Control message is sent, and now a rendezvous is created. In this case, there's a socket forwarder that is established that provides even more optimized communication than the HTTP equivalent, which then allows for a symmetrical capability in terms of that optimized communication between the client and the actual service. Excuse me. There's a number of connection modes that you want to be aware of when looking at the binding. Both relay and hybrid are available. The hybrid option is actually the most interesting, because it'll actually attempt to upgrade your connection to a direct connection. And what I mean by a direct connection is that after some initial message exchanges over the bus, over the fabric, the bus will actually start inspecting some of the heuristics coming out of the outbound messages for looking for port information and clues that it can use to actually make a guess as to what the actual physical socket location is of the client. and it'll actually attempt to establish an upgrade between the client and the service. And if this isn't possible, then the basic relay is used as demonstrated in the earlier examples. So let me actually show you what this looks like graphically. The service establishes a connection over TCP port 828 outbound. The client also establishes an outbound connection. A control message is routed, and a socket forwarder is established between the client and the service. And then, provided that the right guess is established, which Microsoft has indicated they have about north of 85% success with, a direct connection between the client and the service is established, bypassing the bus entirely and providing direct communication between the client and the service. I'll say that again. In the event that a successful upgrade takes place, you now have direct connectivity between the application and the service, which is going to maximize the performance and minimize latency that you do have to take into consideration anytime that you're traversing the internet. So this is a very, very powerful concept, and one of the things that comes up often is I get questions around, how can this really be secure, or how does this work? And the reality is that if you've been using your chat software for any period of time, this capability has been available to chat clients for a long period of time. In fact, if you actually want to test this, what you can do is establish a chat session with a friend, and then have you ever noticed how if you send a file or an image, at first the progress bar actually moves relatively slowly, and then sometimes all of a sudden it seems to make up time very, very quickly. What's happening is really the same idea here, in which a direct connection between your friend and yourself is being established, thus bypassing a lot of the latency. So this is actually technology that's been around for quite some time and can yield significant performance benefits when doing hybrid composite application development. So let's actually take a look at that. We'll actually show this binding in action in the last demo. Go ahead and close this, my start page, and go ahead and open up the solution here. And on the server side, what I do want to show you is that I've set the connection mode here to hybrid. I could have left it as a default, which is relay, but we're leaving it as hybrid. Everything else is pretty much consistent with what we've looked at previously. I have the WCF ABCs, including the selection of the NetTCP relay binding and my shared secret as part of my binding configuration. And so now what I want to do is, the first thing I'll do is actually prime the demo here. And what I found in this demo is that the upgrade isn't always successful the first time, but I have about 99% success the second time. So let's actually go ahead and run this. So I'm establishing a connection outbound with my service, and I'll wait for that socket connection to be established. And I'll do the same thing now on the client side. And so the client will start sending messages, and you'll see them being received. And now the important thing to look at is to see if the upgrade succeeds. And what you'll see here is that we went from, let's see here, 38, 102, 125 messages up to about 200. I really think that we can do better, though. So let me actually try this one more time to really give you a taste for how significant the performance improvements of direct can be. So I'll go ahead and establish that connection one more time on the server side. And start pumping messages from the client. And so messages are exchanged, some negotiation takes place, the socket forwarder gets created, and now we should see we should be seeing a significant increase in the number of messages. Sometimes the direct upgrade succeeds, other times it doesn't. So what I'm going to do is I'm going to go ahead and run this one more time as we wrap up. Perhaps we get lucky. And I just actually want to just make sure that I have the hybrid option selected on both. So we've got hybrid there, and we've got hybrid there. Great. So let me just run this one more time. It really would be great to show you the upgrade live. So that was about 150 messages, 130 messages. So we're seeing some spikes around 200, but there we go. So it looks like we're upgraded, averaging up to between 200 and 300, but it hasn't really been all that consistent. So your mileage will vary with direct, as I mentioned. Microsoft has publicly stated north of 85% success, but your mileage will definitely vary. But you will see a significant increase now, probably peaking around 250 messages sent. So with that said, I want to go ahead and wrap up. I know that we're a little bit over time, and I appreciate folks hanging out. I want to just touch base on some of the features that were announced at PDC 10, excuse me, including the AppFabric distributed cache service and the composition model. One of the things that Microsoft and Neudesic have been talking about is really the fidelity that's taking place and the symmetry between the cloud and the on-premise offerings. And a lot of folks tend to think about AppFabric as two different things. One being the cloud offerings, and another thing being the on-premise offerings. And the reality is that AppFabric is really a unified platform for delivering composite application solutions that transcend cloud and on-premise. And so you certainly will see investments that are poised for cloud, and others that are poised for on-premise, and you'll see the release of those capabilities lagging one another. So for example, Windows Server AppFabric that was released earlier last year in the May timeframe of 2010 includes a distributed caching service. AppFabric capabilities in the cloud are catching up with that. You've had the ability to monitor and manage your AppFabric on-premise applications using dashboards for getting a bird's eye view of the health of your applications. That once again is coming to the cloud hosting with the composition and container model. Desktop capabilities that you use on premise for doing things like transformation and integrating with EAI endpoints providers is also been announced and will be landing sometime in the first half of this year. And then from a Service Bus standpoint, specifically, durable message buffers that will actually store your messages for a predefined period of time in the event that your service listeners aren't available to receive the message immediately. The idea of factoring your endpoints into topics, which can be thought of mini channels or networks by which you stitch together your interested parties and your publishers of useful events. More investments around eventings, push notifications, and discovery. So there's a lot of work that's being done at Microsoft around AppFabric, both on-premise and in the cloud. And there's a number of resources that are available to you. One of the questions that comes up most often is how much does it cost? And here's some information around the cost of Service Bus. Some resources that were certainly useful in putting together this content and the relationship that we have with the product team at Microsoft. Clemens Vassars is a principal program manager and architect on the AppFabric team. I highly recommend his blog for getting really unique insight into the technology. Aaron Sconnard, a good friend of mine, has a white paper out, which is the developer guide to the Azure platform, which includes AppFabric And then the MSDN page for all things AppFabric, both on-premise and the cloud, is msdn.microsoft.com /AppFabric. As a reminder, the previous 2 sessions on WCF4 and Workflow 4 are available to you on the Neudesic website at these URLs, and we will be announcing the timeline for the final session in the webcast, which is enabling the hybrid enterprise, which will actually bring all of these technologies together and talk about how AppFabric really is Microsoft's new middleware strategy for delivering composite application scenarios, both on-premise and in the cloud. So with that, I do want to make available to you, and you can follow up with Meredith and we'll provide some contact info here. If you want to do some architectural deep dives, if you want to dive deeper into the technology, if you want to talk about how hybrid composition might allow you to better realize investments, both existing on-premise, provide some guidance and rationale around what assets might make sense to migrate to the cloud, and more importantly, how those assets communicate back to your on-premise resources, we would be happy to provide some design sessions from the comfort of your offices or remotely. So feel free to request that if you're interested. And here's contact information for that. So info@neudesic.com. Feel free to reach out to me with questions, comments, thoughts, either via email, and the conversation continues on Twitter at the following handles. And be sure to use the one AppFabric hashtag, because we'll be watching that and making sure that you're getting your questions answered. And in fact, here's the date for the final webcast in the series that will tie everything together on February 9th, building composite apps with AppFabric, which you can find more information on at neudesic.com. So with that, I know we've got a number of questions in the hopper. I'll turn it over to Meredith and be happy to get to as many questions as folks are willing to hang out to talk about.
Thanks, Rick. All right, so one of the questions that came through was, is it possible to register the same listening service from large number of machines, few thousands, each with a unique address on the SB, and call the service of each of the machines from a single client? Would the SB be able to handle that load, and what would the influence be on the pricing? Is this a valid use case for the SB?
It's a great question. So I'll paraphrase, make sure I understand the question. To what extent does the service bus scale? Does it support the ability to provide upwards of 2,000 connections, be it client or services, or one client to 2,000 services, and what are the cost ramifications of that? And then certainly, I think there was a naming. Question. So the way that the resolution happens in the service bus is by the name, right? And so when I publish a message, as I did in the demos, to root Windows.NET service bus, etc. The way that resolves to my service is that the service is actually also using that name, right? And so the answer to your first question is yes. You will use the same name to create those subscriptions. In terms of scalability, the service bus is built on a highly reliable fabric, which is comprised of thousands of machines. And so while I don't know specifically the extent to which there's been work done at 2,000 level, I certainly feel comfortable saying that the scalability limits at this point are probably theoretical, and I would encourage you to test that out. I'd be happy to drop a note into the product team and get a concrete answer on that, though. Great question.
Thanks, Rick. Another question that came through was, what are the requirements to run the AppFabric-based service, just .NET 4, and what about the OS requirements?
Great question. So you download all you need in order to work with service bus is .NET 3.5 or 4 are supported, and you can go out to msdn.microsoft.com /AppFabric. which will give you a landing page to the Azure AppFabric page, which then you can download the SDK. The October SDK is the latest one. That gives you all the bits in order to create the client and service stack. And at that point, that's really all you need. So you can work within Visual Studio 2010 to target .NET 3.5 or 4, and Visual Studio 2008 is also supported. In terms of operating systems, off the top of my head, I want to say Windows XP on up, but certainly take a look at the resources online to make sure that your operating systems are supported. But I would really look at it as base that on the requirements for .NET 3.5 and up, as well as Visual Studio, and then your server requirements. But XP on up, Server 2003, I want to say on up should be a no-brainer.
That's been very helpful. Thank you. Another question that came through is, how do durable message buffers differ from MSMQ bindings?
So really, really good question. And so the answer is really, it's kind of providing the internet scale equivalent of MSMQ, right? And so whereas exposing public queues over the internet certainly isn't impossible, it is somewhat cumbersome, requires, again, some of the traditional approaches to punching holes outbound and inbound. Durable message buffers would actually give you all the benefits that we've talked about here, that allow you to really traverse those limitations and then provide a lot of the same durability capabilities that you would look to MSMQ today to provide. Great question.
Great, thank you. Just as a reminder to everybody, to ask a question, click on the Q&A verbiage tool in the top left corner, type your question, then click the Ask button. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. The first question: was this content helpful for your business? Yes or no? Great, thank you, everyone. Second question, please rate the presentation content. Excellent, good, or poor? Great, thank you. Last polling question, would you like us to schedule a follow-up? Yes or no? Thank you, everyone. If there are no further questions, we'd like to thank Rick again for the wonderful presentation. Today's webcast is a part of the AppFabric series. We'll be hosting the next webcast in the series, Building Composite Application Services with AppFabric, on February 9th. We'll be reporting out more information about the February 9th webcast, along with a link to view today's recording. If you have any further questions about this presentation, please feel free to email Rick. And Rick, do you have your email that you can pull back up?
Sure. Let me just share my desktop here.
Perfect. Again, thank you so much, everyone, for joining us, and we look forward to seeing you in our next webcast. You are now free to disconnect. Thank you.